Greetings, math friends. We are going to take a look at this function h of x equals 2 times the square root of x squared plus 3x. And we want to find a function g of x and a function f of x such that when we compose them, that will give us back the h of x. So in other words, what we're doing is we're taking a function and we're decomposing it. And we're also given the restriction that we don't want either f or g to be the linear parent function, which is just x. Because that's really trivial, and we don't want something that trivial. We want something a little more interesting, because that would be the easiest thing to do, is to just claim that g of x is x, and f of x is what we see here, so that every time that I see f of x here, I just replace each x with x. So not interesting. What we can do is we can come in here and look at the piece under here, under the square root, and notice that it's an entire function itself. It is, it would graph a parabola, so it's a quadratic function. So we have x squared plus 3x is a function by itself. If we pull that out, we need to replace that open square root with a variable. And in this case, everything is written in terms of x. So we're going to pull that out and say 2 square root of x. These are two functions. This is a square root function, and this is a quadratic function. And now we need to name them. I have two functions. I got them by pulling apart the function h. One of these has to be function f. One of them has to be function g. If we look at this, we are composing f and g with g on the right. So g is being placed inside the function f. So since I pulled this out of here, we would place this back inside here to complete h of x. So this is going to be my g, and this is going to be my f. All right, so now when I compose, I put this inside of that, and I will return to this. So these are two functions that would work for this. Now, I do want you to notice we put this restriction on here, so we just didn't call this x and this to be identical to what h of x is. In other words, there is an implication here that a decomposition is not unique. There can be more than one decomposition for a given function. So keep that in mind. If you do a decomposition and you check with somebody else and they say, oh, well, I've got something different, don't automatically assume that you have a wrong solution. You should verify by composition that your solution works as well as their solution to make sure that you have what you intended to have. All right, for our next example, again, I have h of x declared here. This is the square of x to the 4th power plus 2x squared. All right, so overall, this is an 8th order polynomial. And I, again, want to find a g of x and an f of x that we can compose to give me h of x. And again, we don't want something generic like the parent function here. But also, I want to show you two different solutions for this one so that you can see that it is possible to get to more than one correct solution and also not be the parent function. So if I show you two examples, we know there's at least a third one because the parent function could also be declared here, and we can get this trivial solution. So the first thing that I want to do is very similar to the thing that I did before. We notice in parentheses that this is a 4th order polynomial. So I can just pull that out. So that is a function all by itself. And then if I pull that out, I need to replace that empty set of parentheses with something. So I'm going to call that x. And we can put the parentheses in there, or we can leave the parentheses out at this point. so it's x squared. It looks a little better without the parentheses, I think. So now, if I want to compose this, I'm going to put this inside of this, so all of this would be squared, and then we would be back at h of x. So that is an option there. So in this case, this is going inside of there, so this is my g of x. And then it's going inside of here, so this is f of x. So now I have that f of x is x squared, g of x is x to the fourth plus 2x squared. So I put this into here, and I'm back at h. All right, so that is one solution. So we'll call this solution 1. All right, I want to do a second solution. And for this, this one may seem like I've pulled a fast one on you, but I'm going to declare that g of x is x squared. Well, that's funny because over here I declared that f of x was x squared. But if I call g of x x squared, everywhere that I have an x up here, I'm pulling out an x squared. If I pull out an x squared here, I'll have x squared. If I pull an x squared out here, I'll just have an x. So I'm reducing the exponents here by a factor of 2. So f of x will be x squared plus 2x squared. All right, so to compose this, again, I'm putting g of x into f of x. If I put x squared into here, I will have x to the fourth, and if I put x squared into here, I'll have x squared, and I will be back at what I started with here. So this is solution 2. All right, so these are two possible options. Now, that interesting thing about this solution set that I've given you is that in the first solution set, I called this x squared, and in the second solution set I was able to call this x squared, and we noticed that the other function that was left out is actually different. Now we could take this one step further. I could do solution 3, and I'll go ahead and do that where I show you where I choose one of the functions to be the linear parent function, which was restricted against here. But if your directions don't restrict you against this, this is certainly a viable option. So just for a little more completeness, I want to go ahead and declare this. So we're going to say that g of x is x. So everywhere that I see an x, I'm taking out an x. But then I just have what I have before. So f of x is going to be equal to this thing. So now, everywhere there's an x here, I would put an x, and it looks identical. So this is why we don't like this. That's why it's taken out in the directions for some of these problems that you work on, because we don't want you to just copy this down and declare that the variable that you're going to insert is the variable that you started with, because this is a trivial solution and it doesn't cause you to have to think very hard like here, and we really want you to exercise your mind. All right, mathematics takes practice and experience, and the practice that you're getting isn't giving you good experience in this case. There's one more thing that we could do to this. Since we know this breakdown, it gives us a clue that if we would have a composition of more functions, that we could break this down into more functions than just 2. So we're going to look at that next. So we've restated the problem slightly. We still have the same h of x, but this time we want to have 3 functions that we can compose into h of x, and again, none of them we want to be the parent function. If we allowed the parent function, we could probably take this even a step further and say we could break this down into 4 functions, eliminating this. So I want to place this in a certain order. Order is important with composition. So I'm placing J into G and then G into F. All right. So the first thing that I'm going to do is I'm going to start with J. And I'm going to go ahead and declare that that is x squared. So I'm going to pull x squared out of each of those, and that will be G. So I'm working from right to left to get at breaking down H here. So if I pull x squared out of each of those, I'm going to have x squared plus 2x squared. So if I put this into here, I would be back at here. So now that I've pulled that out, I'm going to pull out this inner piece and declare that F. So I'm going to revise and pull this out. So we'll have f of x equals x squared. G of x will now be this with that removed. It's going to be x squared plus 2x. And then J of x is going to be x squared. So if I compose here, J goes into here. So this becomes x to the 4th power. This becomes x to the 2nd power. Then if I take that and I plug it into here, I'm going to take all of this and square it according to this, and I will arrive back here. So I've done this in steps to arrive at what I want. This is actually my solution set. I want these 3 functions. So I just did what we did before and kind of used this as an intermediate step. And after I broke this into 2, I revised this and broke it into 2 again. So I have this. And if we wanted 4 and allow the parent function, then we could declare some other function over here to be just x, and then it would plug into here, this plugs into here, and then that plugs into there, and we would arrive back there with 4 functions. So order is important. We have to keep that in mind. Next, we have to know our target, have a good mind for how functions are going to nest into each other. And don't be afraid to have intermediate steps. This is your work, final example. I tell my students sometimes, don't be afraid to have a rough draft of your math homework, and then you can have a final draft of your homework, just like you do in a language and writing class. Hopefully this has been helpful in understanding some of function decomposition. Cheerful calculations.